Mark, give us some more information about what we're doing here.
Awesome. We're just getting started with our first test pit here and digging down. We usually take the pits that the state requires 60 inches, which is 5 feet. Other counties sometimes require you to go to 6. You know, and if you hit a restriction or something like that, of course you stop right there. But so what we're going to do is we're going to dig these pits. We might dig 2 or 3 of them first to kind of get a feel for the soil. Okay. Then we crunch the numbers to figure out the sizing of the drain field and the reserve area, stake the corners, and finish digging the rest of the pits.
Okay, all right, thank you.
You're welcome. All right, we're going to hop in this pit and we're going to profile the soil. Like we talked about, between the difference between hand augers and backhoe pits, you get a nice look at this sidewall here. When you're looking at it in a pit, you can know exactly where the good soil ends and the bad soils begin. And really what we're looking for, again, is any type of restrictions, water table, stuff like that. For a conventional drain field, which of course we always try to find first, you need 36 inches of good soil. And it goes up from there, you know, for alternative and stuff like that, different levels of alternative, right? So the key is to dig in and try to find those indicators that tell you that there's seasonal high water table, and the deeper they are, the better. We also look for density. Okay, see how this is dense and it's softer up top. So all those factors come into play when we're profiling the soil.
Okay.
As we look at it, we got the project sheets. We'll be writing down the information. Go back to the office, type it up, prepare a nice report to submit to the health department.
Okay. All right. Perfect. Thank you.
And 41 to 50.
Going 2 BTs, or
yeah, you got your A, which is a loam, and give that a 45 rate. And you got your BT1, which is a silt loam, and that is a 60 rate, and you have roots throughout in the BT1. BT2 is a clayier texture, and it's more of a massive structure. So we're gonna give that a 75. And then you got shrink swell clay down at the bottom. Very bad shrink swell clay at the bottom. That's probably a 120 rate, which is the worst rate that there is. Your color for the BT3 is 10YR 68. That's brownish yellow. For the BT2 is 10YR 56, which is yellowish brown. And for your A horizon, you got a 10YR 33, which is dark brown. I'm seeing water table redox indications as shallow all the way in the A horizon. This is going to have to be an engineered drip because of the shallow water table that we're seeing pretty much right on top of the surface. We've got the gray, we've got the redoxomorphic features right there. So this is going to be an elevated plus 6 drain field with water table at the surface.
So Mark, when you're saying this, the different terminology that you're using in layman's terms, you know, what does that mean to, you know, me or, you know, your client?
Sure. Yeah. So this is going to be a drip system. This is going to be a highly engineered drip system, which
okay.
is far from a conventional drain field. And the reason for that is for one, the soil type in this area is, you know, it's known for being, you know, poor soils, and we're finding that in this soil profile.
Okay.
Right here. So we've got seasonal high water table that's perching, and it's going to be a big drain field, expensive drain field.
Wow.
Yeah.
Okay.
Yeah.
All right. Thanks, Mark.
All right, so we're still in the same pit, but this is an example of what you really don't want. I mean, this is a high clay soil. I mean, it's called a BTSS. It's got slicking sides on it. I mean, it shrinks and swells when it gets wet and when it gets dry. And that's what's causing the problem up above it, is this shrink swell soil below it, because water hits that and just stacks up right on top of it.
Okay.
So that's below that. Above it, though, we have a sandier soil. I mean, you can see the difference between between this one and that, you know. And this is definitely much more what we want to see. And if it didn't have this right below it, this would be great. You know,
Okay.
this would be a good, soft, friable. I mean, it breaks apart, and you can hardly break that. You know, I mean, it's very, very dense. So this is good. This is bad. But
Okay.
that's what's causing the problem.
All right, thank you.
Yep.